Alrighty guys, so as you're getting out your book, you should be on page 433. You will follow along with my notes and copy these into your book. Then you should have had handed out a blue paper that has questions 13 through 15. Those you will fill out on your own and turn that in as a note check. So today we're going to be graphing translations of the quadratic parent function. We'll talk about what that is in just a second. And be able to identify and distinguish among transformations. So right now we know transformations as a translation, rotation, dilation, and a reflection. Now these all have to do with polygons and moving shapes around on a coordinate plane. So in the same idea, we're going to be moving around a function on a graph. So the function y equals x squared, or f of x equals x squared, is a quadratic parent function. So again, you'll hear me say more f of x as we move through this unit. So the parent function is the most basic function of a particular category or type. So it is just the original function, so everything is based off of x squared. So if we complete the table for this, you'll notice kind of what you have started to see when we do tables. We have 9, 4, 1, 0, 1, 4, and 9. And again, I'm just plugging these into x squared. So you can see as we go and graph these, we should have the exact same points on either side of our vertex. Okay? So again, parabola is a U shape, so we want to be careful when we draw this shape, and I'll even get it kind of wrong sometimes. But we want to be careful that it's not so much a V, that it is a curved U. So this is what we call the parent function. It is just the original x squared. This is what we would draw. And again, we can always draw from a table. So the next part is using words such as vertex, maximum, minimum to describe this to this graph. So I'm going to keep this here, guys. I'm going to write these off to the side so you can see this more. So if we're trying to describe this, something that could we say, well, where's the vertex? Vertex is located at 0, 0, or we can say even at the origin. The parabola has a minimum at 0, 0. Okay. We could also say that the function is increasing from 0 to, now this was different. The other day we had a graph that stopped. Well, this one has arrows. It's not stopping, so it's increasing from 0 to infinity. All right, it's not stopping. It's going to keep going. All right, which then also means it decreases from 0 to negative infinity. And yes, that is a thing. And we'll talk more about negative infinity next week when we're talking more about these graphs. So that's kind of describing what these are. And again, I'm going to stay on here, but we're going to move on to number 3, because number 3 says to draw the axis of symmetry as a dashed line above in graph 1. So I'm going to go ahead and grab my line tool up here. I'm going to draw an axis of symmetry. Now, axis of symmetry goes right through the vertex. So that's going to be my axis of symmetry. And then it asks to write an equation of the line. Well, this is something, guys, that we've got to remember here. It's a vertical line. That's always x equals. All right, so that's something that we're going to have to remember here, because this is a question that's going to be asked a lot, to write the equation for the axis of symmetry. So the axis of symmetry is x equals 0. All right, so that's kind of an introduction here to the parent function, kind of describing where it is at, how do you draw it, filling out the table, and so forth.